Now, if you follow the algorithm very carefully, you may notice a very important question, that is how to select the seed customer. So this question is pretty tricky because we really don't have a very good solution to select the seed customers. So definitely we can utilize our human intuition. So let's see, if you have m equals to 2, then maybe you will choose a seed customer as this is one seed customer and then this is one seed customer. So if your m equals to 3, probably you will try to select seed customers like this, this, or this. So our human being can have some intuitions such that those customers are chosen based on some experience. But in general, how can we choose the seed customers? So here we provide you with a meta-heuristic based algorithm. So different from the simulated annealing method, which we introduced in the TSP solution, here our critical idea is how can we choose the decision from a relatively big space, right? So for example, if we have n customers and then we have m trucks, then this number of choices, that will be, you have n customer and then select m trucks, m centers. So this is combinatorial, which is a very big space. So actually, for this kind of problem structure, a meta-heuristic algorithm called genetic algorithm can be applied. So what is genetic algorithm? So for genetic algorithm, we typically will encode the decision as gene. For example, we can encode our decision into binary 0, 1, 0, 1, blah, 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 okay? So once we define a mapping from our decision to this binary sequence, then we define a gene. And then we can utilize a lot of knowledge in biology related to the gene operations, and that can help us get the optimum solution in a relatively efficient way rather than enumerate all possible decisions. So one of the two famous operations, we call it crossover operation. So that indicates if you have two parents gene, let's see, we have one parent's gene is 0, 1, 0, 1, 0, and another parent gene which is 1, 0, 0, 1, 0. And then the crossover means some part of the gene can be swapped to generate a new gene. For example, let's see, this two part, we have a crossover, so that will generate a new gene. So then from this operation, we provide children gene from the parent genes by swap part of the genes. So this is an analogy of biology. And then definitely we can have another very famous operation called mutation. So that means if we have a parent gene, let's see, still 0, 1, 0, 1, 0, you can have a chance that this gene has some mutation. Let's see, this one, we have a mutation operation. That means the gene suddenly changes to its opposite. So from 0 to 1. By doing this, we also can have the children gene. So typically, we will combine the crossover operations and the mutation operations to generate the children genes. So the typical process for genetic algorithm, step 1, we will randomly generate genes. So this one, we will formulate our pool of genes. Remember that each gene corresponds to a decision. And then each decision, we can evaluate the cost of the decision or the objective of the decision, so we can have a score. For example, if we want to solve optimization problem with maximize cost, then the score will be the cost. And then step 2, we will randomly select parents from the gene pool. And then after we select these parents, typically we can have some rules, that is a higher score indicates a higher chance to be selected. This makes sense because we want to find out the best solution from the existing solution have higher objective value or better quality. And then after we select the parents, we can do our children generation based on both parents or single parent, depending on your crossover or mutation. And then after you get the new gene, you evaluate it and then add to the pool of genes. So we have another generation of genes. And definitely you will order the genes based on their scores and then only leave a part of the genes to improve the quality of our gene pool. So after you do this for multiple iterations, from parents generates children, and then from all the current pools, and then keep generating children, and finally you can gradually improve your solution. Then the gene with the highest score will be your solution.